Greetings and welcome back. Last time we defined what our array is. It is a structure that has a pointer to data, where the data of the actual array lives. It's got a length and a capacity. That is our array. We then defined the function to create an array, which included asking for memory, returning a successful array if it was allocated memory successfully, with an initial length of 0 and a capacity of whatever we give it in main. And in main, we called this function with an initial capacity of 10, and we printed the array address to prove that it was actually giving us an area in memory. So today, our mission is to add a push function which will push an entry onto the existing array. It's an interesting lesson. I'm going to do it the obvious way, but there's a catch. There's an issue with the obvious way. There's a trap, and we'll discover it together. So the first thing I want to do is create a new function, which doesn't return anything, and it's just called push. And we're going to give it our dynamic array, call it ARR, and we want to give it a value that we want to push into the array of type integer. I'll close off that function. So the first thing we want to do is add data. The second thing we want to do is update the length, so that we know how many spots in the array we actually have data for. So the first thing, array.data, and at the array.length position, because an array starts at 0, so the array.length position is empty, we'll assign it value. And then we're going to update the length as the existing length plus 1. And we're going to return. The next thing we want to do is call our new function after the array's been instantiated. So we will call push, pass it the array, and let's give it a value of 5. We then want to print the length of the array, which we would expect having called one time, it will be a length of 1. So array length is d with a new line, and we put array.length in there. We'd expect that to be 1. And then we want to print the contents of the array. So array contents are, and new line. Then we'll set up a simple for loop, which will loop through the array based on its length and then print out what the contents are. So for initial statement being an int of I, starting at 0. Our condition is I is less than the array length. So we'll loop over everything in the array according to its length. And then we'll increment I upwards. And then just inside we are going to printf the value, the integer value, with a new line. And we're going to put the value as array.data at the point I. Semicolon goes there. And then return 0. So this looks like it should work. And let's see what happens. We will gcc -w all -w extra. The output being dynamic array first try. And this file is called dynamic array.c. Now let's run the program. Dynamic array first try. And that is very interesting. What we'll see is it's giving us an address of the array, but the length is 0. Remember, we expected it to be 1, and we actually pushed a value of 5, but the contents are not showing. Can you guess what's going on here? So the issue lies in how C actually takes in variables and executes them in the stack. So our function push, which is called here, we're passing in the array that we instantiated on line 38. Inside it, it actually creates a copy of the dynamic array, and it performs all the logic on this copy itself. So here, the copy's data is a pointer to the same memory address. And so this line actually does add the value to the next slot in the heap. But it's changing the length property on the copy of ARR, and its length will be 1. Now, when the function returns, the copy is just discarded. In the stack, when a function is called, it apportions it, as far as I understand, a frame on the stack. So this push function at this point gets called and a frame gets added to the stack. It takes up part of the memory of the stack. And then when it returns, that frame is removed from the stack, and that memory that it used to occupy is overridable. And so what we are doing here is taking a copy of the array, looking at its pointer, which points to the actual array's address, memory address in the heap, and assigning it a value correctly. We are then adding a property. We are updating the length property on the copy of the array to 1, and then we're sort of removing the copy itself. And so the initial array here afterwards has data that has been written, but we can't actually access it because the length is incorrect. So what we need to do actually is to pass in a pointer to the array rather than the actual array itself, because C will make a copy. So this function needs to change. It needs to take in a pointer to a dynamic array. And when we call it, we need to use this notation so that it gives the pointer the address of the array that we initiate on line 38. We then need to dereference from the pointer. Now that's putting in a pointer, we need to dereference it using this notation. And we are putting it in parentheses because of the order of operations. This dot data calculates before the dereferencing operation, and so therefore, like a maths expression, we need to tell C to do this dereferencing first and then reach for the data. And same here, we need to dereference the array. So now it's actually looking at the array rather than the address. And here we are dereferencing that as well. Now let's see if that worked. Did that fix it? We will try second try here, compile it, and then let's run it. Dynamic array, second try. And here we see it's given us a new address for the array. The array length is 1, and therefore we can show the contents of the array, which is 5 that we pushed in here. So this is a working push function that is appending a new value onto the array that we defined. There's also, now I'll take you through some syntactic sugar, because apparently this happens a lot where you have to dereference things and it's kind of awkward to be dereferencing and using the parentheses. So what they have done is given us some shorthand or some syntactic sugar. And instead of all that, you just do an arrow. So instead of parentheses, star, and then the dot, it's just an arrow. And for the length, it'll be the same thing. Array arrow, we'll dereference it. And then instead of this whole operation here, we can just increment it with a plus plus, which makes me feel more like a programmer. Let's add in push the array, and we'll add in a value of 6 just to make sure. Sorry, yeah, we need to use the address just to make sure that multiple values work. Let's save it, and we are going to compile, output, dynamic array third try, and we're going to point it to dynamic array.c. And if we execute it now, dynamic array third try, we see that the address is a real address, the length is 2, and the array contents are 5 and 6. So we've learned this cool little syntactic sugar. Thanks for watching. The next time we will be filling up the array up to its capacity, and then we'll have to grow it somehow. And we'll look at different strategies on growing the capacity of the array. See you then.